Hello, my name is Jonathan Bisnet, and this is the fourth video in a series on MOSFET transistor circuits, logic circuits. Excuse me. And what you'll see in this one is the AND gate. So, excuse me, the NAND gate. So in this particular case, it's really the inversion of the AND logic. So you end up with a 1 if neither bit is on, or one or the other of the inputs is on. If both of the inputs are on, then you end up with a 0, which would be my red LED. Otherwise, the green LED signifies a 1 on the output. So you'll see here, if I press just one of these, nothing changes. If I press the other one, nothing changes. If I press them both, it goes on. If I let go of one of them, it goes back off. So the only time I get the red LED on is if both the buttons are pressed, which is basically NAND logic. The way this circuit is organized is similar to what we did for a NOR gate. You'll notice again it has 4 transistors. There are 2 P channel and 2 N channel. The difference here, or the interesting part here, is what you'll see is it's virtually just the opposite configuration to create the NAND gate. So whereas before we had the P channel transistors in series coming down from the positive rail and the N channel transistors in parallel coming up from the ground or negative rail, we have just the opposite situation here. We have the P channel transistors in parallel and the N channel transistors in series. And what this does is create basically somewhat the opposite of a NOR. We get a NAND. So you'll see how these are ultimately wired. I've got basically the 2 P channel transistors again here in the first position with separate inputs, the green input, the yellow input to the gates. They both are off these red wires here. They both have positive potential to the source, and then what you'll see is the drains are tied together with this white wire, and the output of these two is sent over to the N channel. So really these are wired in parallel. For the N channel transistors, again you'll see that the input signals, the green and the yellow wire, are carried over to the gates for these 2 transistors as well. The difference is I have the ground or the negative rail going to the source of one transistor and the drain of that transistor going to the source of the other transistor, and then finally the original input from the parallel P channels is combined with the output of the drain of the second transistor, such that then is wired down here to the LEDs, which are in the same configuration they've been for this whole video series. So really what you've got is something like the opposite of the NOR gate, at least in its normal configuration. So I will show you the schematic here. If you take a look at it, you'll see pretty much what I'm talking about. You see the 2 P channel transistors at the top, and you see the 2 N channel transistors in the middle on the bottom. And the way the P channels are connected, they're both connected to the positive rail. The gate of each of them comes off of one of the switches, and their drains are in essence both wired together to the output. Once again, whereas with the N channel transistors, one of them is tied to the negative rail, and you'll notice that the The drain on that one is then tied to the source on the next one, and its drain is then tied to the common point where all the transistors come together and go to the LEDs. So again, as I say, you note the parallel and series nature of the way this circuit is organized. Thank you.